Hello, I'm Johnny Delgado and I'll be your tutor for today. So, you're having questions about variables. You hear them used, you're trying to learn programming, but what are they and why do we use them? Well, it's easy. Variables are just containers for information. That's it. I'll say it again. Variables are containers for information. That seems like a kind of abstract concept. Um, Back when I was teaching high school, and when you're teaching programming to like the little kids especially, they like candy. So we would give them cups with M&Ms. And the value would be how many M&Ms or what color the M&Ms were, and the cup was like the variable because you can do things to change the amount of M&Ms that are in there, pouring more in or just eating them. You can write on the cup and give it a name because all variables have names. So you can think of it as a container for information. And most variables are made up of three core types. These are at least it's easy when you're learning to think of them as the three most important parts of a variable. That's the name, which is just what you call it, and that can be whatever you want. The type, which is what kind of information are we going to put in that container, and the value, which is what is the information that's going in that container. And this sounds still really abstract and weird, but let me give you an example in Java so you get an idea of what I'm talking about. So to declare an integer, declare just means create the integer. Let's see, I want to make an integer, so I have to use the command int, int, that's it. And named I. The name is going to be the letter I because it's easy to remember because they start with the same letter, and I'm not going to be super fun and creative right now just to keep things simple. So int I, we have now created this box, this container called I, and it knows that it's going to be holding an integer, a whole number. So it doesn't have anything in there. I can try to print it and it's not going to do anything. Sorry. So I'm great at talking and I'm great at programming, but doing both at the same time is not a skill I have. So bear with me as I write some of this out. So it gives me an error. Why is that? We hover over it and it says, local variable I may not have been initialized. We'll talk about that word later. For now, just know that it's not enough to create the box and then print it. You actually need to give it a value. And in programming, that's called setting the variable. So we say I equals, this is not an equivalency operator as it is in math. In Java, the equal sign means the variable I gets the value, in this case, 5. So now, oh, look at that. The error went away and we can print this. So now we have a container, like a cup with 5 M&Ms, a cup with an integer value of 5. So instead of writing the number 5 a bunch, I can just say I. And that doesn't make our lives a lot simpler now, but when you actually need to remember if you're keeping track of the number of students in your class, instead of having to remember that number, you could just say int number of students equals whatever. And then that can change year to year, but every single time when you're doing this program, it's just going to be that same variable name. So let's try running it, and we're expecting to see the number 5. I always recommend trying to predict your outcome before running it, just so you have a little mental confirmation if you get it right. And sure enough, it's a 5. Great. I get to keep my job. So next, we talk about getting a value. And, oh, well, we already did that. Getting a value and printing it to the console. Ta-da! Look, see, I'm an overachiever. When we use a variable, when, for example, we're feeding that variable into a print statement, into the println function, we call that getting the variable. And I want to emphasize that we're getting the value inside that variable. there's a reason it's printing the number 5 and you don't see I, the variable name, in here at all. When we say system.out.println I, and I is a variable name, it's just going to feed that value into the print statement. So we're only concerned with the value for that part. So then now, what's the word initialize? It's, if we get rid of this line, this is going to complain and say, hey, you have to initialize it. So clearly doing this is initializing in some way. And what initializing is basically just giving your variable a starting value. You can think of it like that. And to initialize something like a floating point number, we would say float f, keeping with our same naming convention, equals 4.2 f. Now, the letter f comes in there because it's a float, and if we removed the letter f at the end, it would just be a double. Don't worry about that too much for now. I'll show you how to write a double in a second. But we can also print floating point numbers. And here, remember, we've set it to 4.2 because this line is functionally the same as doing it in 2 steps like this. It's just an easier way. It's a programming shortcut. You don't have to, but if you want to declare and initialize your variable all at once, here's how you do it. And we're looking for the value of 4.2. Let's see if we're right. Yes, we are. Wonderful. To do the same thing with a double, I'll just give that as an example because if you're just starting out, there's not much of a reason to pay super close attention to the differences between a float and a double. Just know that they're ways of representing numbers with values after a decimal. So we could say double D equals 2.1 and put that, and now it's okay with that. You see there's no error. And we try printing it. And sure enough, yes, it gives us 2.1. Notice how when I'm making a float, when I'm initializing a float, the letter F has to be after the value. When I'm creating a double, you don't need the letter D or the letter F or anything, you just put the number. You could also initialize it without the decimal, and it's just going to assume that there's a decimal value in there. See, it prints it out as 2.0. The same thing happens if you write float 4. It's going to assume there's a decimal place because floats and doubles are numerical data types that have values after the decimal. Think of it that way. And final data type, well, okay, 2 more. We need to talk about strings. And I'm going to tell you what a string is in a roundabout way. A string is a collection of characters. Now, what's a character, you're asking? Well, a character is it's a letter or a symbol or a number, but not in a numeric way. It's basically just representing one letter or symbol or number. We could have an integer that's 55. We cannot have a character that is 55. I'll show that to you. Here, let me go ahead and make a new section, initialize a character. So for characters, we would say char or char c equals, I said I would do 5, so let's try that. And then let's try to print it to make sure everything is fine. And sure enough, it does print 5. We can do other things with characters too. It can be, the letter S, and it doesn't matter, capital or lowercase, both are acceptable. It can be a period. Awesome. You might be thinking, oh, well, could it be 0.5? You might not have been thinking that exact thing, but oh no, it can't. Because 0.5 is a string, or we're going to think of it in string terms. It's a string made up of 2 characters, the decimal point and the number 5, both of which are characters individually. So when I say strings are groups of characters, that should make a little bit more sense. And why do we use strings though? Why bother? I'm sure all of this is, oh Johnny, how am I ever going to use strings? I have numbers. That's all I ever need. Well, going back to the example with, keeping a variable for all the students in your class, if you're like me and have a hard time remembering names, you might want a variable that is student's name. And let's say it's Johnny. Uh, no particular reason. And so when you print out this string s equals Johnny, oh, there we go. Now I can remember the name of my favorite student. I assume that's what you'll be thinking if I were in your class. So we can create lots of different variable types, but why bother? Programming should be useful. What can we do with this? Don't slow down there. We're getting to that. We can change the value in a variable. There are many ways to do this. And this is great. Sorry if you hear the dog barking. I live right near a dog park. You can change variables in different ways. And we could do this. Let's say your class gets a new student, and you would need to say int students in class equals, let's say you have 12 students in your class at first, and let's go ahead and add some print statements just so we can follow this along. Okay, spell that wrong. There. Like I said, talking and writing at the same time, not my strong suit. So that can result in the number 12. Great, we have that. But let's say people are so excited about the programming class you're teaching, they all want to join. And 5 students join at once. So now you have students in class equals students in class plus 5. Whoa, this is so advanced. Can we add a variable to itself? Yes, you can. So all this is saying, remember, this is not a statement of equivalency. This is saying, open up the variable box, students in class. Take the current value, 12, and add 5 to it. And put it together, and let's see what that is. The new value is hopefully exactly what you expect, 17. So now there are 17 wonderful students in your class eager to learn programming. Let's say we don't need to write it that way. Let's say instead you switch classes. You're no longer teaching this intro programming class. You're now teaching the AP class because you're so great at that. And instead, the principal comes over and tells you, okay, well, the 12 students you were teaching before, now you're going to teach these 7 students. So you can just set a variable to a new value. And sure enough, that value is 7 here. You could do math in here. You could say, okay, instead of copying my old value, you could say 12 plus 5 and just write it out manually. All of these things are ways to change the values of a variable. And we can add 2 integers. We already did some examples of that up here, but we can add 2 different values. So we could say int a equals 5 and int b equals 2. And int sum equals a plus b. I can't do int c because remember, c is what we named our character up here. And let's go ahead and try to print that and see what that is. And I believe you should expect that we get the number 7, and we do. So this is adding 2 different integers together. Totally possible. You can do the same thing with floats. You could say float q equals 7.7 and float w equals 6.9 and I need a sum. Float sum. Actually, some of you may have noticed that I forgot to write the letter F at the end of my floats. Float sum equals Q plus W here. And we try to print that, and sure enough, boom, 14.6. I'll pretend like I did that calculation in my head and I knew the answer beforehand. But now, what happens when we add strings? That's a different story. When it comes to integers, 2 plus 2 equals 4. We all know that. We're familiar with that. In programming, when we're dealing with strings, string, let's call this S1 equals the number 2. And string S2 equals also the number 2. I just like making this joke. My students like it, and you know what? I can't hear anyone to critique my jokes, so I'm gonna stick with it. Let's see what the sum is when we add 2 plus 2 in strings. Bonus points if you realized 2 plus 2 equals 22 when it comes to strings. This is not a number. You can think of it as a word. It's a string. We can't do mathematical operations to this without actively converting the string to an integer or a float or some other numeric variable type. To give you a simpler explanation, because this is a joke, but an example that I've had written on my board for a week is if we have one string that is hot and the other string that is dog, add those together and it is hot dog. I may or may not be excited for dinner. This is called concatenation. This is combining things to each other. You'll usually see this in the context of strings being added together, but it doesn't have to be. This can be, you can concatenate a number on the end of a string or in the middle or however you want, or you can keep chaining variables together. But just remember that when we're talking about concatenating strings, even though we're using the plus operator, we're not talking about adding the values numerically. We're talking about new string equals first string plus second string, just shoved together. So to recap, variables are containers to store information. They're great to let us modify the information as we wish, storing them for later, using them multiple times. If you're storing a whole number, use an integer. A floating point number, use a float or a double. A single character, a symbol, number, or letter, use a character. Multiple characters, like a word or a combination of letters and numbers and symbols, use a string. And you can do different kinds of operations to them. You can change their value. You can set one value to the sum of other values. You can do all kinds of mathematical operations: division, subtraction, multiplication. You can add different types together, like floats and integers. But remember, when you're adding strings, they will concatenate onto each other and just stick one onto the next. I'm not going to get into adding different types of variables to each other. That'll be the topic for a different video. But I hope you learned something and had a good time. And until next time, I've been Johnny Delgado. Thank you so much. Have a great day.